YouTube, this is my first in a series of videos in which we're going to confront the imaginary unit, or the value that is going to allow us to solve quadratic equations for which there are no real solutions. So I start here by saying, you know what, sometimes we're going to have to solve equations like this one you see here, which says x squared is equal to a -4. And basically what I want to consider is this: we have some equation here where we have a squared value on the left and a constant on the right. To solve this, we would just solve it as we normally would and take the square root of both sides, but really we end up answering this question, hey, what could we take times itself to get a -4? And I just want to point out here, if you try -2 here, -2 squared, you actually get a +4. And if you try +2 squared, you get a +4. In other words, there's no real number that we can think of that ever, when you multiply it by itself, you get a -4. And so kind of to get a way around, a way around this problem would be to introduce what we call the imaginary unit I. And basically, we use I as just kind of shorthand notation for the imaginary unit. And we say that I here is equal to the square root of -1. And what makes that profound is essentially that we could rewrite this answer over here on the right as this. We'd say the square root of -4 is really the square root of -1 times a +4. And we would say by our product property of radicals, we could actually split this up and say, well, that's the square root of -1 times the square root of +4. And see, the thing is, I already know how to handle this square root of +4 part. It's just this square root of -1. We're going to refer to this as I. And so I get I times the square root of +4 here. And so basically what I want to point out is, you see this statement right here, the square root of -4, we're always just going to rewrite it as I times the square root of +4. And that's going to be our way around it, because now I could just say that this is plus or minus 2 times I, where the square root of 4 is 2. And I'll just take that times I that was already out front. So you can see, if we were to take the square root of +4, it would have just been plus or minus 2. When you take the square root of a negative, we just call whatever plus or minus that square root times I. And so our very first property here basically says that if r is some positive real number, then the square root of -r is the same thing as I times the square root of +r. In other words, you just put an I out front, you make what's inside the inside part, the radicand, positive, and then you treat it the same way. So as an example, I provide here, it says the square root of -3, same thing as I times the square root of +3, and it's really as simple as that. So before we move on to the second property and talk about why it's profound, let's consider this. We say, well, if I is equal to the square root of -1, well, if you square both sides of this statement, then what you get is I squared on the left, and when you square a square root, you just get what's in the inside, the natural radicand value here. And so we have to know going forward that I squared is equal to -1. And the reason why this is profound is looking back at this equation right here. We said, can we think of a value that when we take it times itself that we get a -4? Well, we were able to think of a couple. We say plus or minus 2i. And so all I want to do is I just want to check this out. I say, what happens when I square this plus or minus 2i? And so when I square this, I would get, well, anything positive or negative squared would be positive. So 2 times 2 is 4, and then I times I is I squared. And what I basically want everybody to recognize is that we're going to go forward saying that I squared, well, that equals -1. So really I get 4 times a -1 here, which is -4, and it follows that we get -4 is -4. So what we want to point out is that imaginary unit I, it allows us to take square roots of negatives and rewrite it as square roots of positive by putting the I out front. But it's also unique in that it is the only value that we've ever constructed that when we take it times itself, you get a negative output. And so we say by this first property here in this table down here, it says if we were to take this I times the square root of +r and square that, you would get I squared times the square root of r squared, which is just r. You basically get this -r because this negative, or the I squared, is a -1. So in this example we gave here, hey, the square root of -3 is I times the square root of +3. Just put the I out front and make what's in here positive. We would get I square root of 3 squared, which is I squared, times the square root of 3 squared, which is just 3. In other words, that I squared is going to make that 3 negative, and look, you get a -3 and you took it times itself. So what I want to do is I want to use this property to kind of simplify these roots over here, but they're all square roots, and they're all square roots of negatives. So the first thing I want to do is really the easiest step. We say the square root of -25 is I times the square root of +25. So by putting the I out front, we make what's in here positive, and then we say, let's evaluate it from here. What's the square root of 25 if we know it? And I actually know that's 5 times 5. So I'm going to get plus or minus 5 times I out front, and so we really just get plus or minus 5i. And again, you know what, if this had been the square root of 25, we would have written plus or minus 5. Well, in this case, we write plus or minus 5i, just introducing that imaginary unit. So now here, we say, well, again, the first thing I want to do is write this as I times the square root of +27. And then we're going to use our rules with radicals to kind of simplify this. I know that 9 is a perfect square, and I know the square root of 9, and it goes into 27 evenly. So we could rewrite this, and without having to split this up as I times the square root of 9 times the square root of 3, we're just going to say, since I know the square root of 9 is 3, basically I know this is going to be 3 times I out front, and this is times the square root of 3, and we should get in the habit of writing a plus or minus here. And then last but not least, what if I already have, something out in front of my square root? Well, we'll just multiply it by whatever we take out, which in this first case is going to be the I part, and make this a positive 8 on the inside. Now I would think to myself, can I think of any perfect square numbers that go into 8 evenly? And I can think certainly of 4. So taking the square root of 4, which is this 2 out front, 2, we need to multiply it by everything that's already out there. So this is going to simplify out to negative 10I root 2, and we won't worry about the plus or minus this time around. Cheers.